This presentation is on DDoS execution and mitigation.
So this is the Scapy script that we used in order to simulate a DDoS attack from multiple attackers to a target. The first line of the Python script imports the Scapy library. The second line here sets up the packet that we're going to send. We set the destination IP on layer 3 to 192.168.1.5, which is the IP address of our target in this simulation. Then for layer 4, we send a TCP packet, which is SYN, which means that the target is going to be sending back SYN-ACK packets that aren't going to make it back to the attackers. The port we're sending this to is going to be set to a random number so that the target can't block specific ports that we're sending the packets to, and we tell the destination port to be 80, but we're not going to be receiving these packets back as the attackers. In the raw portion of the packet, we send 1,000 bytes of random characters so that we can flood the network interface. The third portion simply says we're going to send the packet, not return any information about the packets, and we're going to send it on loop as fast as we can until we cancel the script. Here's a video of 3 attackers simulating an attack against one target. You can see the Wireshark traffic for the target is flooded with a bunch of junk TCP packets. We're sending SYN packets, and it's trying to send back SYN-ACK packets. And when we pull up the analytics on Wireshark, we can see that we're sending an average of 3,361,000 bytes per second, which is about 3 megabytes per second. We can verify this by looking at the time span and seeing we've sent a lot of bytes over. And this scales linearly with how many attackers you use by about 1,000 bytes per attacker.
The whole premise of a DDoS execution is to send numerous packets via SYN or UDP packet floods, and instead of sending it from one host, which is very easy to block because it's one IP, you instead want to spread it across numerous, if not thousands of hosts on a large-scale attack. And you want to obfuscate that host as the command center or use an alt machine, and you want to have that program that will send the packets for those other machines as a logic bomb, so it doesn't execute until those packets are actually out. And if you want a more advanced DDoS program, you should randomize packet lengths, obfuscate and alternate encoding, as well as cluster packages in varying manners. Once you develop the script for executing the DDoS, that begs the question, how exactly am I going to get this script to other zombies? Well, there are multiple hacking methods you can use, such as remote code execution or reverse shell, in which you would establish a reverse connection through the command line so you could transfer over that script. You could do a Trojan to get that script on that other person's computer, or package it as an extension with a legitimate extent program. You could do ARP poisoning, address resolution protocol poisoning, and redirect traffic to a spoofed web page. Or you could also do a worm, which is a self-propagating virus that would spread it and would automate it more. Or another way to automate it is through a rogue access point, which would redirect Wi-Fi traffic.
Hello, my name is Nick Samarusti, and on this slide I will be going over DDoS mitigation techniques from an infrastructure level. This will include different networking practices and server configurations that can make the network less susceptible to DDoS attacks. The first method I'll go over is blocking malicious IP addresses and controlling packet flow through rate limiting. Blocking malicious IP addresses will help reduce the load on the network, and this can be done through firewalls, access control lists, and intrusion detection systems. Rate limiting sets a limit on the amount of bandwidth a network device can use in a given time, and by setting rate limits, network administrators can prevent a single host or system from consuming a massive amount of bandwidth. The next DDoS mitigation technique is creating subnet limits. Subnet limits can segment the network, which isolates potential attacks within specific network segments. It's also important to change default subnet settings to prevent vertical movement through a subnet after a compromise. By segmenting the network, successful DDoS attacks have a much smaller impact, and services can be shifted to unaffected subnets. Lastly, keeping multiple servers, if possible, is another method to prevent DDoS attacks, since a server under attack can split the traffic to other servers. Having multiple servers allows for low distribution, which allows servers to share the incoming traffic if one server is receiving more packets than the other. These methods together mitigate DDoS attacks by having network decentralization and redundancy, meaning that it is difficult for attackers to take out all servers at once.
Hi, my name is Noah Little, and I'm going to talk about mitigation techniques for DDoS attacks, specifically automated methods. So one of the popular automated methods is a IDS, which stands for Intrusion Detection System. And this is going to monitor your traffic and search for any suspicious activity, specifically a DDoS. But the IDS can also find any other suspicious activity in the events of different types of attacks. And then it will generate some type of alert or some type of information system, such as like an email, or it's going to send it to your admin center, and it's going to tell you that a DDoS attack is currently happening. And then you have intrusion prevention system, which is just like the IDS, but it's going to be able to actually intervene whenever an attack happens. So you could set probably how it intervenes, whether it's blocking certain ports, limiting the amount of traffic that's allowed to come in, maybe opening up another server. But IPS is actually able to do something whenever an attack happens. Smaller companies may benefit from some open source IDSs or IPSs, such as Snort or Bro, while these larger companies will be able to use like Palo Alto and Cisco to actually intervene. One thing you have to do with an IDS and IPS is you actually got to change up the default maybe methods that it uses to block systems, or else an attacker can find ways to get around the actual safety net that you've put in. And then I currently work for Ameren, and we actually have an IDS system for whenever we get a high amount of network traffic. Actually, I get emails about it all the time. Sometimes it's an attack, sometimes it's pretty much nothing for the most part, but that's super important because we don't want an attacker to be able to take down the entire electric grid for Ameren just because a high amount of traffic came in.
My name is Tarek Zamadi, and I will be going into the DDoS mitigation technique of incorporating machine learning. Machine learning is a subset of artificial intelligence that focuses on the development of algorithms and models that enable computers to learn and improve their performance on a specific task without being explicitly programmed. In the context of DDoS mitigation, machine learning can be a powerful tool. The key crux of the benefit of machine learning lies in its ability to adapt to evolving threats and changing network conditions. As DDoS attackers continuously develop new techniques and strategies, traditional rule-based detection systems may struggle to keep up. By leveraging network and analytics, machine learning algorithms can learn to detect DDoS attacks with remarkable accuracy and efficiency. These algorithms analyze vast amounts of network data, identifying patterns and anomalies that indicate potential DDoS attacks. Two particular effective algorithms for DDoS detection are DDADA and DDAML. These algorithms address the vulnerabilities of software-defined networking, or SDN, architectures to DDoS attacks. They offer adaptive strategies to counter the evolving sophistication of these threats, ensuring network security through efficient and accurate detection methods. DDADA, which stands for DDoS Detection Algorithm Based on the Degree of Attack, focuses on analyzing network traffic patterns to identify anomalies suggestive of a DDoS attack. It introduces the concept of degree of attack, a metric that quantifies the severity of the attack based on features like flow, length, duration, size, and ratio. Thresholds are then employed based on this degree of attack to make decisions on whether the traffic is malicious or legitimate. On the other hand, DDAML, or DDoS Detection Algorithm Based on Machine Learning, utilizes machine learning models trained on the network traffic data, including both normal and DDoS attack data. These models learn to identify complex patterns and characteristics of DDoS traffic, enabling them to classify network traffic as malicious or legitimate for real-time detection. To implement machine learning for DDoS mitigation, organizations can leverage various tools and frameworks. Zeek and Suricata are popular open source network monitoring tools that provide rich network data for analysis. The Elk stack, which includes Elasticsearch, Logstash, and Kibana, offer a robust platform for collecting, storing, and visualizing network logs and metrics. For building and training machine learning models, there are several widely used libraries and frameworks. Weka is a collection of machine learning algorithms for data mining tasks, while Keras and TensorFlow are just powerful deep learning frameworks. Scikit-learn is a versatile library for machine learning in Python, offering a wide range of algorithms for classification, regression, and clustering. By incorporating machine learning into DDoS mitigation strategies, organizations can significantly enhance their detection capabilities. And these are the sources.